set up the SiTF test. SiTF is a signal transfer function for the thermal imager, and it will help us determine the saturation points of the camera versus the signal and temperature. We need this so we know where's the linear range that you're working with, and as well as using this gain factor, or what we call the SiTF, when we want to convert the analog to digital conversion of the frame grabber into something more meaningful, like temperature units. So from the list, we need to select the SiTF, double click on the test setup, and we have here, let's remove the clutter a little bit. Okay, what we need to do is to set up source on a source stage, so that the radiation source will be behind the target wheel if we have a source stage. So here, in this case, we selected the black body. We need to select the target. So we select the target, make sure that it's either a square or a step target. Usually, preferably, it's a square target. We need to set up a table. We're going to ramp the black body from a negative temperature to a positive temperature, so that we can plot the signal versus the temperature. So in this case, we have, it's called radiation intensities. We can double click on it, or before we double click on it, we want to set the size of the vector. You can determine as many points as you want. Right now we're set to 3. I want to increase that to get something more meaningful. So I'm going to change that vector size. So I hit the size. I would assume, let's do something that's odd, because we have to do negative number of points, then go through 0, and then a positive set of points. So let's say 15. Okay. And now, of course, since we didn't fill in the entries, the table entries, we need to double click on it. And we're going to start, let's say, at, we want to make sure that we're in saturation. So let's start at -3. We're going to use the autofill function, -3. Step jump of ½ a degree. And click the fill button. So we see it's going to go from -3 up to 4. So I guess we could have started at -3.5, and so we'll go from -3.5 to +3.5. Make it something like symmetrical. Doesn't have to be, but it's easy to do that. Okay, there's another function here, or parameter. It's called radiation source initialization. Well, in order, we need to initialize the black body. We want to make sure that it's in differential mode. So we select differential. We want to set, let's say, set to -1 degree or some sort of temperature. This has more effect when for setting up the region of interest. So we need some sort of initial temperature. It could also be -3.5 or whatever, but as long as you have the flexibility of setting the any temperature that you want, as long as there will be some sort of contrast between the background and the target display, then you'll be able to select the region of interest. This is the reason you need this temperature, initialized temperature. Okay, so the next thing we need to do, of course, is to make sure, okay, we have the region of interest. Again, the region of interest will be set in during the test. In this case here, we have something, in this case, we have a vector of region of interest, and of course you can set it manually. or use the region of interest selection during the test. Save. Exit. Thank you. Okay, we're going to do SiTF test, and we're going to first open up the test setup file so that we can update the parameters if we need. So we double click on the SiTF test. We have a list of parameters that we can change. Basically what we're looking at in the SiTF is we want to see the gain of the imager in the linear range and where it saturates in the plus and the negative temperature zones. So we have three outputs here in the system. One is called the out SiTF, or in other words, the gain. This is the slope, and we store this in a variable called SiTF slope, and the value is in counts per degree, because the frame grabber or the capture card converts the video into digital counts, and we want to know the ratio between digital counts to per degree. And when we use this value in other tests, we can convert the readings, the signal readings from the frame grabber into units of temperature. This will be effective, let's say, in a 3D noise test where we want to present the results in millikelvins. We also have another output called out R value. This is the R value, which signifies how closely we fit the points on the graph to a straight line. And the closer, it's a value between 0 and 1, the closer to 1, the better fit. And we may want to, we're interested in that value, because if it's not close to 1, then either the measurement was too noisy, we have to repeat the measurement, etc., etc. And sometimes we also have an offset. That means that at zero degrees, there may be a slight signal offset that you'll still be able to see the signal. That means that you may have to correct that, or the system, it has still some effect due to external factors. So these are the three outputs that we have in the system. What we need to do is set up the source stage. The source stage, we need to use the black body because this is a thermal imager test. So we select from the drop down the source, the black body source, and then we need to select the target. We either use a square target, or preferably we use the square target. Sometimes, if we don't have a square target, we can use a step target in the system. Then we have what we need to do is a table that we're going to ramp the black body from a negative temperature to a positive temperature. These values are entered in this vector. It should probably be an odd number of, the vector size should be an odd number, because we want it to pass through 0. We want to check this SiTF at 0 degrees. So if we have an odd number, we'll have an even number on the negative side, an even number on the positive side, and the extra reading will be on the 0 temperature. What we want to make sure when we run the SiTF is that we start from a temperature that we're deep into the saturation node, because SiTF is like an S curve. So we want to find the two saturation points, the positive and the negative. So we set it to temperature difference. Let's say in this case, this camera, we're going to set it to something like -5 degrees, and we'll jump at whatever temperature step value you want to jump. Could be like half a degree or a degree, depends on how accurate you want the measurement to be. We also need to initialize the test so that we can perform some setup during the running of the test, such as setting the region of interest. So we start, first of all, we make sure that we're working in a differential mode, and we need to set the temperature, or we need to set the temperature to some value that there will be some sort of contrast, so that we'll be able to use it for determining the area of the region of interest. Theoretically, if we would set it to 0, there's no contrast difference, and you wouldn't be able to see any the target. We wouldn't be able to determine where the region of interest is. So that's why it's important to have some sort of value here. Click on OK. Finally, we have another region of interest vector, which determines the values of the background and the signal region of interest, where we're going to make the measurements, measure the signal difference, because SiTF is what we call delta V, V signal minus V background divided by the differential temperature. Okay, and we save it at the end and close and get ready for running the test. Thank you. Okay, after we've set up the parameters for the SiTF test, all we need to do is to execute or run the test. So we select the test and click the Start Execution button. What we need to do is wait for the parameters to set up, or the controller and the hardware to set up, such as the black body set up to its initial value. Select the source, the radiation source on the source state, which would be the black body, the target, which is the square target, and just wait until it reaches its set point. Then we're going to select the region of interest. As you can see here on the left-hand side, this is the table that will be filled when we ramp from the different temperature intensities, and we will measure the signal at each temperature setting. Not yet, but yes, this is one. Okay, so black body has reached the first initial set point. We need to follow the prompt on the window pane. The yellow, we need to set the yellow outline is the region of interest for the target, and the red is the background. Let me just zoom in a little bit. As you can see, we want to set it as large as possible in the projected target, and the background has to be within the field of view of the collimator. So you can position it anywhere you want. Let's put it on the right hand side here. We're assuming that the noise component is the same, if not similar, within this area. Once we've completed setting up the region of interest, all we need to do is click on the OK button, let the software do its thing. Okay, so now we're going to the first set point and we're going to ramp up. Alright, so we're next to the last point right now, and okay, great. So test is finally completed. What we can see here is the graph of the SiTF. This is the area, the linear area of the SiTF, and here's where it's starting to saturate. You see this green line. This is the SiTF value, or the gain, or the angle of the gain, which represents the gain of the system. And the output, it gives us the SiTF, or the gain. This is the number of counts per degree. There may be a slight offset. It's not exact. That means that that at 0 degrees there's a slight offset. And what else? And this is the R factor. This is how close you're able to make the fit. So if an R factor of 1, that means it's a perfect fit. And here, if we want, we can uncheck. If we have a very noisy system, or we can uncheck some of the points here to manually make the best fit. But this is, of course, only if you need to. We can, of course, save, export the graph and the points and do post-processing if we need to from here, or we'll do that in the test summary. So once we've completed the test, all we need to do is click OK. All these values are stored, and the test is completed, or almost completed. It's doing a post-processing where the temperature is going back to delta T of 1, or differential temperature of 1. Once we've completed running the SiTF test, we can see the test summary and or generate a test report. In order to see the test summary, we double click on the test. We can see here the SiTF value, which is the gain of the system, an offset, and the R value, or R factor of the system. On the attachments tab, we can see the plot that we did, or that we measured, any of the points that we ignored. Here are red. The green is the SiTF, or the gain that we measured, which is the value that we have in the measurement. And this is the actual plot. This, of course, can be exported, again, by selecting this button and clicking the export button for each signal. We can also review the parameters, the setup parameters that we did for the test. These are, of course, stored and saved in the database when we want to look at a later point at the test that we ran. And then we have also the summary tab, which includes the part number, the serial number, the imager, if that's important, and the operator. We can also run a report. So on this tab, we need to select we need to select Quick Basket. I just want to point out that on the other tabs we may have other tests that we run. So anything that's selected in the Quick tab, we'll see in the report too. So right now we'll see also the last run of the NETD and SiTF. I click on the Create Report. Use the Quick Basket. Let's make the graphs small. Click the Create Report. We see the summary of the UUT and which tests were run. Here's the NETD, SiTF with the graph and its values. And that's about it. Thank you.